Welcome to the Climate Hive Show. What do you solve? Where we sit down with global game changers tackling the climate crisis with real solutions. I'm Kevin Drolet, aka Kedro, here with my co-founder and co-host Mike Higgins, aka Higo. And today we're super excited because we have a guest that's going to remind you of Star Wars. They're doing super futuristic stuff, and we'll get to that in just a moment. Troy Helming is the founder and CEO of EarthGrid, PBC, a public benefit corporation developing plasma powered tunneling to underground critical infrastructure like transmission lines and fiber. And before EarthGrid, he founded two notable US renewable developers, Tradewind Energy and Pristine Sun Solar. He's also the author of Clean Power Revolution and a frequent speaker on grid build out and clean energy entrepreneurship. And in 2024, EarthGrid won the Startup World Cup Grand Prize, reflecting growing interest in its plasma boring tech and supergrid vision. So, Troy, we are super excited to talk to you today about EarthGrid and learn all about it. And to kick us off, I'm going to turn it over to my good man Higo, who always throws out the first question because that's how we do.
That's how we do it. Troy, great to have you. I can't wait to learn more about this.
Thanks for
We're
having me.
my first question actually is a little pre-problem. I go way back to there was a time when this company didn't exist. It was an idea in your head or maybe several founders' heads. And we like to understand out of the gates, like what was the aha moment for you when you decided that I've got an idea, I can solve a problem, this is what it is. Like take us through that aha moment.
Yeah, sure. As a seasoned entrepreneur, I have a tendency, as all entrepreneurs do, to start companies to solve problems that we experience ourselves, right? And so over my career building solar farms and wind farms, the biggest challenge or the biggest impediment to the growth of low cost, clean, renewable energy, homegrown renewable energy, the biggest challenge is lack of transmission lines because it
Mm.
takes 15 years to get, new transmission lines built in this country. And most of them never get built because communities fight them along the way. So that is kind of an underlying theme. We were in a bar having a happy hour with my team at my solar company in 2016, and we had just downsized a solar farm in California by 75% because the grid couldn't handle it near the solar farm. Had we been able to go either over or under 2 miles of protected wetlands, we could have gotten to a stronger part of the grid and built the whole project instead of giving up on 75% of our revenue for 20 years. So anyway, we're in this bar, drowning our tears over beers because the cost to go underneath the river and creek and wetlands was so expensive. It killed that idea, and the time it would take to get a permit to go over would have been like 2 years plus if we even could have gotten it, and we
Mm.
would have lost our contract. So anyway, drinking beers. One of my solar engineers, he's a former Navy SEAL, Dominic, and he's bragging to his girlfriend about how SEAL team used to go underwater and they would cut through the side of enemy ships with a plasma cutting torch to take over the ship. Plate falls in, water rushes in, SEALs go inside, pow, pow, pow. We're like, dude, you're a badass. Anyway, wake up in the middle of the night that night, and I was like, huh. He said it was 20,000 degrees, could take your arm off. That's got to be hot enough to bore through rock. Has anyone ever tried that? Just couldn't stop thinking about the idea. I was up all night researching and found some stuff from like the 1970s. Los Alamos National Laboratory did some tests. And then a new administration came in, the program was shut down. Anyway, long story short, I finally built a prototype late 2017 and started testing, punched a hole through a boulder of granite. Didn't tell my wife or my son or anybody. It was a little secret side project with me and a couple of mechanical engineers I brought in to build this prototype, and it worked. I was like, oh my goodness, this could be really something. It could be either a nothing company or a $1 billion company, but I gotta pursue this.
Man, I think that might have been the greatest aha moment story we've heard on this show.
It
I mean,
definitely
I'm
is.
serious. For the
Yeah.
whole Navy SEAL tie-in with the plasma torch. I mean, man, what an inspiration. What a moment to have been like, lightning strikes with that idea, right? Man,
Yeah, I don't know why or where it came from or what or why I popped out of bed, but I'm very grateful for that moment.
man.
Trey, when you were having the insight and you're sort of building the project, were you thinking specifically about the challenge for the solar company, or were you thinking,
Yeah.
sort of what your focus, some of the breadth of what you're focused on now, which is actually a broader concept, or how did that develop?
Yeah, I mean, it started with just power lines because I know that to get a permit for overhead, as I said, 15 years, but if it's underground, you can get the permit in like 1 or 2 years, maybe 3 years at the most. And so, and it's a sure thing, because no community opposition can stop it if it's underground underneath the rights of way of public roads. So I was like, this is a big deal if we can solve this. But yeah, as I was thinking about it, and I hired a publicly traded engineering firm that did a feasibility study, and they were like, yeah, there's other use cases. You could move water, gas, fiber, eventually freight, and even people through tunnels that you bore, because your biggest operating cost is electricity to run these lightsabers, plasma, and electricity on a wholesale basis is really cheap thanks to the proliferation of solar and wind. Yeah, our retail rates at our homes, it keeps going up, but the wholesale rates are going down because solar and wind have no fuel costs. So wholesale rates are quite low, and in some cases even go to zero or even negative because of how much solar and wind is being put onto the grid. So yeah, I started thinking about all the other applications, including mining and even space applications, boring out habitats on the moon or Mars or whatever.
So how are things? So can you give us a sense of because this is new technology and I think like as new technology comes on board, like people sometimes are a little resistant. I love the mental picture I have when we were talking in the pre-show about like, sort of Luke Skywalker with like it is the seal or whatever at the boat, but it's also you're cutting through more than a boat, like you're cutting through a rock. You're actually creating tunnels.
Yeah.
Um, but how are things going for the company? And are you have projects that you're working on? What does that look like?
Yeah, we completed our first project, was approved in California, had to go through the full environmental review. So if we can get our technology approved in California, we can get it approved anywhere, basically. But yeah, as you can see from behind me, this is a picture of our two-torch plasma excavation system. And as of July of this year, after basically 7 years of testing, over 1,000 tests, 100 different rocks, and figuring out our recipe for each type of rock, which are our trade secrets that will never patent. But we do have 162 patent claims. But anyway, yeah, we commercialized our first product. We're currently negotiating scope, specs, and terms for 7 projects to use that machine. So that's not a tunneling machine. Well, I guess it could be used for large tunnels as a kind of a road header for those who are familiar with that type of machine. But it's primarily used for excavation. So like carving out foundations for homes or buildings, digging ditches or trenches in rock where you have utility lines that need to go in, carving out caves or bunkers or whatever. So that's the excavator, and it looks like we'll start seeing some fairly significant revenue over the next 18 months with that machine. But it's been a long time coming. The tunnel boring robot, which is the picture behind me on the other side, is a 3-torch system, and that's in manufacturing. We had to develop a solid state spoils removal, basically using vacuums to extract all the sand and dust. Because at 6,000 to 27,000 degrees, plasma turns everything, whether it's soil, clay, sand, and even the hardest rock, turns everything into dust and sand. But we have to get it out, including a little bit of lava. We create some man-made lava in high silica rock. So using our vacuum system turns lava into silica sand, removes all that. And that was a really hard problem to solve. 7 iterations, lots of failures, lots of learning, and that took a few years to figure that out. But anyway, the tunnel boring machine should be ready for commercialization by first quarter of next year.
I think when we talked again in the pre-show about the spoils removal, you guys are using wind and pressure, right, to blow it out. Is that how it's working?
Exactly. Yeah, exactly. We wanted to come up with a non-mechanical system with no moving parts if possible. And that was a tall ask. But that's what the engineering team, have a great team of 10 engineers led by Mark Park, who's former Rivian, building, electric trucks, electric vehicle platforms, which have, really high safety tolerances and so on and so forth. But anyway, so yeah, we ran computational fluid dynamics in software on basically a supercomputer that we rented. Sometimes the simulation would say something would work. We would build the thing in real life and it didn't work, or it worked part way or whatever. So like I said, 7 iterations. and we call it Thunderdome is our code name.
It's awesome.
But yeah, it works. We create a violent tornado or vortex inside the tunnel, moving the plasma heat around and suspending the air. And so basically suspending the particles, the sand and dust and bits of rock, and fluidizing all of that so that the abrasion of that violent windstorm, sandstorm, if you will, breaks up the bigger chunks into little small chunks. So everything turns into sand, which is easy to vacuum out. And you can pull, with our powerful vacuums, we can pull that sand, up to 8 kilometers or 5 miles at a time.
And
Man.
is that a new innovation also, this that you've created? Is it like solving this problem? You've created another solution, basically? Is that
Yep. We filed another patent with, I think, 18 or 19 claims with that. Some of it is off the shelf. I mean, there's vacuums used in mining applications for many years, but we tweaked it for our purpose.
Is this torch working like, like drill bits? You know how they go down, what, 60 feet and then put a new drill column in and push in another 60 and a new drill column in. I mean, how are you pushing this thing through the ground?
Right. At the moment, we're using just a pretty standard pipe jacking system where the cutting head at the front, the world's first plasma cutting head, is just being pushed in basically by a rod that pushes it in, and you can keep adding sections to the rod and going.
Okay.
That's a temporary solution for fairly short tunnels where you don't need a lot of maneuverability, to turn left or right, because we're non-contact. We're not pushing against the rock and,
Right.
grinding away and replacing drill bits or cutter heads all the time. And we're not using water or lubricants or chemicals or drilling mud like bentonite, none of that. So our waste product, what's usually muck, that you have to pay to get rid of and take that toxic stuff to specialized landfills and specialized water treatment plants for the liquid part. We don't have any of that. It's environmentally benign. So the idea, though, is to be able to have maneuverability. We're going to put the cutter head on a tank, basically a small miniature tank underground. We're a startup, right? So we're doing the simple thing first, proving that we can, do a 10-meter long, 40-foot long tunnel, 1 meter diameter, 40 inches roughly. Once we do that, then we'll start adding those other features.
That's right. That's a great because you're removing the material that's in front of the torch without, yeah. So man, a tank. So underground maneuverability. So you'll be able to go left, right, up, down, be able to drive around. That'd be a
Exactly.
fun job.
It's a robot, no humans, but it's semi-autonomous. So the operator on the surface, there's all these sensors like gyroscopes and things that are used by the oil and gas industry that we're utilizing for navigation, guidance, and control. But yeah, that's the idea.
Can you discuss a little bit further? Because, our show is Climate Hive and, we care about, the climate and you're really, your innovation, as you're saying is like, you're not creating all this toxic waste that goes into a landfill, but can you talk a little bit more? And that's obviously, your background being in solar and something that you clearly care about as a human. Can you
Yeah,
talk a little bit more about the impact, on, climate and I guess for framing, I'm kind of curious, like, because I know that, like, in the mining industry, they're sort of one of the last industries that's really cares about, sustainability, let's say. It's just not kind of in the DNA of the mining industry, but you're coming in with something that's a solution, that does solve some problems. Can you speak to that, sort of what exists right now in this industry and, what you're solving as in regards to climate?
for sure. I'll start with the mining application, then I'll go to where my heart is and how to accelerate clean energy, renewable energy, and improve the efforts of mitigating climate change. So on mining, we can eliminate the first 4 to 5 steps of a typical vein mining process. I don't know that we can help too much with, like top down or mountaintop renewable mining or whatever. But when you're following a vein, whether it's gold or platinum, silver, whatever it is, Inconel, you're not able to remove everything, and it's a pretty toxic process, as I think you probably know. Some use arsenic or cyanide or whatever, as part of their process. But we can eliminate drilling, blasting, primary crushing, secondary crushing, and then separation of the ore metal from, the gravel and sand and dust. And our process does all of that in one shot, right? We turn the rock into sand and gravel and dust. We either vaporize it or turn it into sand. And so that takes care of drilling, blasting, and both of the crushing steps. And then our vacuum pulls everything out. And what happens to the ore, and we've tested this, creates little BB-sized, balls or spheres of ore. And that can be pretty easily separated in the post-process. We remove all that with our vacuum, and then whether it's a centrifuge or screens or a combination of both, mining companies are telling us that, yeah, we want to test it, but we could probably remove that pretty easily without using all of those chemicals.
Yeah, gold, I've been in gold mines and I've, seen where the veins used to be because they're literally veins in the wall, right? In the rock. So your process, you're going to take all of that out and then extract it and then separate it when it's extracted.
That's
So
right.
you're not just boring around and leaving the gold so it can go in and be taken out. You're taking it all out at the same time. Hmm.
Exactly. Exactly. Yeah,
Fascinating.
it's not going to go away. A metal ore is just going to melt, and then our process of extraction cools everything. And so as it's spinning around, it's just going to naturally form a sphere. It won't be a perfect sphere. It'll be lumpy or
Right.
whatever. But yeah, that's again needs more testing, but that's
Right. Fascinating. I mean, I'm in Colorado. It's a mining community, so I've
yeah.
been down some of those. Now, what about something like coal? Could this work for coal? Because obviously coal is flammable. So, you go in there with
Yeah.
that kind of heat, wouldn't it catch the shaft on fire?
Well, it won't work for coal. Will it catch it on fire? It could if we were using normal air as our gas. But if we know we're boring a tunnel through a coal seam or a natural gas
Okay.
field, or whatever, we would switch from air and go to gaseous nitrogen. So there's no oxygen in the process, so nothing could ignite or explode or whatever. We've actually tested our process with propane and natural gas.
Guys
So,
thought of everything.
oh, I'm sure we haven't. There's probably a bunch of unknowns that we have not thought of. I've certainly learned that over the years is that
There's always something else to invent.
yeah, yeah. But to Kevin, or I guess Kedro, I'm going to get your nicknames right here, but on climate. So what's close to my heart is accelerating solar and wind. And as I think your listeners probably know, solar and wind and batteries have been something like 90 to 95% of all new power plants added in the USA every year for like the last 6, 7 years. It's mostly solar, wind, and batteries. There's very little new coal, gas, or nuclear being added, a little bit here and there. However, it could be a lot faster. The biggest impediment to the growth of renewables is lack of transmission line and grid interconnection challenges. So
Right.
80%, 4 out of 5 solar farms and wind farms never get built. They're put on the back shelf because of lack of transmission lines being built. Again, it takes 15 years to put new transmission lines. And so when I wrote the book, The Clean Power Revolution, a little over 20 years ago, I said we need 270 new transmission lines, regional transmission lines, to unlock cheap solar and wind and get it from where it's windy and sunny to our cities, our data centers, and our factories. How many new transmission lines, regional lines have we built in the last 20 years? Like 2. And we needed 270 back then. Now we need close to 1,000 new transmission lines because of the electrification of everything, vehicles, heating, homes and buildings and so forth, as well as data centers and AI. And the US wants to lead in AI, which means we need a lot of power to our data centers. So EarthGrid intends to build an underground supergrid, a network of tunnels coast to coast that will have power, fiber, and in some cases water, and then eventually maybe freight or even people moving through our tunnels once we increase the diameter, follow the same path. EarthGrid is approved as a regulated telecommunications utility. We're a regulated utility in 46 states, which means we basically get preferred access to put our tunnels under any public road. So federal highways or state highways, county roads, whatever. So that's the long-term vision. We're going to start by putting in underground extension cords to connect a proposed solar farm with a proposed data center to solve the power problem, or wind farm or whatever. So we'll start with little short projects like that here and there, and then eventually start connecting all of those segments into a network where we can move huge quantities. We think we can add up to 300 gigawatts of new renewables to the grid, and for the first time ever, be able to move large quantities of energy from coast to coast. Because right now our grid cannot do that. We have the eastern grid, the western grid in Texas, and they don't talk to each other. But the EarthGrid tunnel network would enable a super grid so that those three grids can, for the first time ever, start sharing large quantities of clean renewable energy with each other and move it across time zones. Like, it's windy in the Midwest, at the exact same time when California runs out of sunlight because the sun's going down and they need that energy to meet the peak evening demand to solve the duck curve problem. Same thing on the East Coast, same thing in the Midwest. We can actually move energy around, and with a strong enough grid, reduces the need for batteries substantially.
That's a really big, I mean, that's a really big vision. I'm curious, like sort of from a headwinds, standpoint. I mean, we're in the sort of situation, at least in the US, we're in the situation we're in. There's some, on the federal level, in terms of what's going on, right? Like resistance to, et cetera, like renewables, these kinds of things. But sort of two different questions I have for you. One is I was thinking about the transmissions in your book. You wrote your book 20 years ago, and only, two were built out of 230 plus that were needed. Um, is that is the impediment there like the utilities? Like why don't we build more? Why is that not happening quicker is one question. And then I have another question, but I'll hold off on my other question. But maybe
One at a time.
could you help us understand that? Like why is it so slow? I don't get it.
Yeah, so most new transmission lines that have been successfully completed in the last 20 years or so are what are called merchant transmission lines, meaning they're owned by private companies. They're not owned by any government agency, federal or state. They're not owned by utilities. They're owned by private companies. And many of those private companies have utilities as investors. But a regulated utility often is unable, it's often illegal for them to put a transmission line that goes outside of their own service territory, and they have to go through a bunch of stuff and rate base it, blah, blah, blah. So that's why they're privately owned. What stops it is community opposition, NIMBYs and bananas. So I'm sure your viewers have heard of those terms. If they haven't, NIMBYs, not in my backyard, bananas, build absolutely nothing anywhere near anyone. I have one of those in my neighborhood. So these are people that slow and stop progress, and they don't need much money. They have a very loud voice. They're well organized, and they can slow projects down by filing, litigation or lawsuits, or it's going to lower my property values, or it's going to kill my kids with EMF, or it's going to be, whatever. It's environmentally insensitive, and because overhead lines absolutely require private land for the towers. They can't put it all along roadways for transmission. Distribution, the wooden poles, yeah, that you can do. But transmission lines, you can't do it. You have to have private property. And anytime you're touching private property, you have to go through a public comment period. And that's the mechanism that NIMBYs and bananas will utilize to slow the project. And they can slow it down for years by filing lawsuit after lawsuit after lawsuit. So that's what happens. That's why over 90% of proposed overhead power lines fail. They never get built because you got, maybe 97% of your path is approved, but that last 3% is two communities and one rancher who says, hell no, I don't want this going over my land. Nope, absolutely not. It doesn't matter how much you pay me, I'm not going to do it. And the project dies. Going underground gets rid of all of that. Because again, if it's following the public rights of way, you don't need these huge towers so you can, follow the roadways. And then there's no opportunity. There's no public comment period. There's no opportunity for landowners to object.
Interesting. Okay.
Powerful.
Yeah, definitely. So I guess that's this sort of, okay, so second question is, so you've already been able to gain access or the authority to build underground across states. Who grants that authority? Like how does that work? And is that something you have to work within like the federal government? Is it state by state or
Oh,
how does that work?
well, the federal government only if you're trying to cross federal land, like BLM land or national parks or national forests, then you would have to work with the feds. And we are avoiding that like the plague and trying to focus on just routes that are easier to get the permit for. And so you go to the AHJ, the authority having jurisdiction, is whoever owns the road. So if it's a city road, you go to the city. If it's a county road, you go to the county. If it's a state highway, you go to the state. If it's a federal highway, you also go to the state. The states work with the feds, but the states have primary jurisdiction for all permitting. And what's frustrating is, yeah, at the federal level, the Trump administration is violently opposed to renewable energy, and there's a huge disconnect
Mm.
because the vast majority of conservatives, Republicans, and I grew up in Kansas, a very conservative state, conservatives want to conserve natural resources. And the vast majority of solar farms and wind farms, like I think over 85%, are in red conservative counties. And
Yeah.
those red counties are often in red states. Most of the wind energy in this country is in places like Texas and Kansas and Oklahoma, Nebraska, North and South Dakota, Minnesota, Iowa. Some of those are purple states or red or blue, but most of them are red. So overall, Republicans support solar and wind to the tune of 75 to 90% of Republicans support solar and wind power, but the federal Trump administration, for whatever reason, does not. So that being the case, it's super frustrating. However, having said all that, uh, you know, these projects, 80% of solar and wind projects, like I said, they're not getting built. And if we build transmission lines, we can make it happen by working with counties, cities, and states to get the right of way. And we've already confirmed this with, I think we're up to 27 counties across 4 states where we've confirmed that our utility status gives us um, almost guaranteed access in some cases, and in other cases, it's not guaranteed, but it would be very difficult to be denied as long as we meet all of the local codes.
It seems to me that there's another third-party aspect at play that might be beneficial to renewable energy resources, and that's AI. Because I've been reading about these data centers, these AI data centers, they need a lot of power, and they need more power than it's available. So, I mean, I think, you know, as in a free market economy, they're going to have to look for all sources of electricity, right? I mean, I've even heard people talking about let's turn 3 Mile Island back on, right? So it's like I don't think that there's any ideas off the table. So maybe that will be beneficial for
You
getting a
think so?
little more wind in the sails, so to speak, for renewable energies as well, right?
That's right. And a lot of the ultimate customers are big tech companies who have mandates to buy renewable energy, and they're trying to get it, but it's just not available because, again, the solar or wind
Can't move
farm
it.
that's been sitting there waiting for somebody to build a transmission line for 7 years, they can't get the power to a substation where it can be fed into the data center. So if we can be the gen tie, the underground extension cord, and make that connection of 30 miles or whatever it is, again, that's what we're hoping to do. And we actually have been asked to give a proposal for a data center project in the Western United States where we're solving that exact problem. So fingers crossed we're able to get that done. And by the way, we've already talked to all of the AHJs, the county, even the federal government, FERC, for that project, and we have tentative, green light from all of the various agencies. So now we're working on trying to get a conditional contract signed with the data center developer.
You
Mm.
know, I just want to like shift for 1 second because even before we started the show today, you were talking about a test that you guys did and the team you've developed and overcoming challenges. And clearly, like in doing what you're doing, this big vision, you have to overcome a lot of challenges. So our audience, we hope, in part for the show, are entrepreneurs and people that are doing big things and we've talked to many amazing people like yourself that are doing big things. But can you give us a little bit of, your thoughts of like, how do how do you get up in the morning and go, I'm going to tackle these big challenges? What are some of the things that drive you and methods? And what would you say to other entrepreneurs that are trying to do big things that run into real headwinds?
Yeah, that's a tough one. So for me, I have this drive, this power of purpose, if you will, which I encourage all entrepreneurs that I meet to find something, find your power of purpose, because being an entrepreneur is a fight, and you're going to be knocked down onto the mat all the time, and you got to have something that's more than money that motivates you enough to get up off the mat, dust yourself off, clean up all the blood, and keep going. And so for me, the power of purpose is clean energy. I grew up, as I said, in Kansas. My dad built his dream home and big 7,500 square foot house, and he put a solar thermal system on the shed behind the house. and it heated our pool, our hot tub, our domestic water. And in the wintertime, we shut the pool down and it heated the hot tub and all of the air in the house. Basically, this thermal solution, propylene glycol and water would circulate through copper coils in the four furnaces. And so we had almost no natural gas bill. And it was one of my chores as a kid growing up to maintain the solar system. And my parents were complaining about, the oil shocks and our dependence on foreign energy. And my mom had cancer, and we believe it was caused in part by the pollution coming from the various coal plants along the Missouri River, because coal is responsible for over 80% of airborne and waterborne mercury. And so, if you're drinking water, either you are a filter or you have a filter. And if your body's the filter, then you're probably drinking some nasty stuff and it gets into our food, our fish, blah, 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 blah. So as a kid, I wanted to help my mom be healthier and reduce pollutants in the air, food, and water. And I had this experience with clean energy and how it not only saved us money, it helped us, feel better about the environment and be more energy independent. So that kind of shaped and formed me as a kid, but there were no jobs in solar or wind when I got out of business school. So went into telecommunications and eventually started the first wind farm company in Kansas, and it became a huge company. It's now a $35 billion division of Enel Green Power. I started that in the late 1990s. So after a couple of other companies where I made a lot of mistakes and learned a number of lessons. Anyway, so that's what drives me, having that power of purpose. And to this day, it still does. And although EarthGrid can do a lot of things in a lot of different areas, what gets me the most excited still is accelerating clean energy.
That's a great story. Oh, your dad was really an outlier, huh? He was
Yeah. Yeah.
Yeah.
He was a guinea pig. It was the first system of its kind anywhere in that part of the country. Yeah, the guy who designed and built it for him came down from, I think it was Wisconsin. Yeah. Anyway, so yeah, he was an early adopter.
so
Real innovator.
yeah.
What an idea.
Yeah. I give a lot of credit to my dad, not only for being an entrepreneur, but for inspiring me to follow the path that I chose.
I have a question because I keep seeing the plasma torches behind you, shifting gears yet again. I think we've shifted a lot of gears. I don't know how many gears we've got, but I think we're on 9. But I don't know what plasma fuel is as I'm sitting there looking at
I was
that.
going to ask the same thing, Mike.
Yeah, I know.
I'm glad you asked it because
I sensed it, but
I
you're
didn't
not
want to
stealing
seem
my no,
stupid.
you're not stealing my
No?
question. No, yeah, I'll always assume the role of the idiot on the call. That's easy. That's a natural environment for me.
No,
But
it's a
what is
great
it? Where does
question.
it come from? And what's its source?
Yeah, shame on me for not explaining how the tech works. But yeah, these torches behind me, you see this kind of green um, plume. It's called a plume, a plasma plume. The way it works is these tubes, which are just stainless steel with a copper electrode on the front and an electrode kind of buried inside in the rear, in the middle of the torch. It's about a 1.5 meter long torch. So whatever, 4 feet. I prefer metrics. It's much easier. Anyway, so the way it works is we create lightning in a tube. And so to create lightning, you just need electricity. So we can get electricity from a generator, from a mobile substation that you can rent or buy and hook up to the grid, which is very common on construction projects. And then you're buying grid power, which is cleaner and cheaper than burning natural gas or diesel or whatever. So you just need a source of electricity. And then what we do is we pass air through the tube over the lightning. You already know lightning's pretty freaking hot, right?
Yeah.
When you pass air over it, the air will become the fourth state of matter, which is plasma. It basically superheats the air, separates electrons from the atom or whatever, or the molecule. And the air is going so fast, it's going at nearly the speed of sound. So it's near sonic speed air. So that's a lot of kinetic energy, physical energy, in addition to the thermal energy, that really high heat. So plasma is basically air that has been superheated to the point where it's no longer air, it's actually a plasma. And so, like I said, it's 6,000 degrees around the edges, 27,000 degrees where you see those kind of green arcs. And so that heat and that kinetic energy turns everything to dust and sand. So there's no fuel, air is free. The only cost we have is the electricity to run it.
And
Wow.
there's this term spallation. Is that what it is? Spallation?
Spallation, exactly. Yeah, that's a term that was new to me because I'm not a geologist, but that simply means rock will turn into either flakes or bits like gravel or sand. So when you hit rock with heat, one of three things can happen. It can spallate, meaning little, as the little tiny cracks in the rock and the air pockets expand, bits of rock will pop off, just naturally pop off. So that's spallation. If the rock has any silica in it, it can melt. So a portion of it will spallate and a portion of it will melt. And if you hit it with even higher heat, like 3 times higher temperature, then you skip spallation and you skip melting and you just vaporize the rock. And it's literally a vapor. And then when the vapor cools, it will turn into a really fine dust or silt.
We like getting the tech school on this
Yeah,
show. We go
no
back
doubt.
and we go back and review the shows because we're like, wait, what did you just say? What did Troy just say?
I just got smarter. And what's the fuel source on the other um, solution? The one
Yeah,
on your
so
left there.
mechanical boring or drilling or excavation, it's pretty much all either diesel or gasoline, where you're using
Okay.
mechanical means to spin a drill bit or spin a cutter head that has, or spin a wheel that has cutter heads on it. And so because we are anywhere from 5 times to 100 times faster, we use a little bit more electricity than a conventional machine, but we're so much faster that our overall energy budget in terms of total kilowatt hours consumed can be anywhere from 40% to 98% less energy for a given project.
Makes so much sense when you say
I've learned a lot in the last 8 years, and we've made, trust me, we've made so many mistakes, but that's how you learn, right? My sport of choice is obstacle course racing. I've been invited to be on the show American Ninja Warrior multiple times, and I have competed on the show. And in that, or I also do rock climbing. You fail on those all the time, right? So you have to learn how to pick yourself back up and like I said earlier, get off the mat. And so it's the same thing when you're innovating. You have a lot of failures, and you just have to have that muscle to overcome failure and not get discouraged and keep trying and try something different until you figure it out.
Yeah, it's one of my favorite quotes is from Edison when he talked about I've never failed making the light bulb, right? I've just invented 300 ways not to do it.
I
You know,
love it.
yeah,
Totally.
I got it wrong, but I'm in the ballpark.
You
But
are, yeah.
no, that's good. And American Ninja Warrior, that's a great show. Yeah, it looks pretty brutal, man.
Yeah, it's not easy. In fact, I just got first place on a regional competition, but I ripped one of my calluses ripped off, so I was a bloody mess afterwards. But at least I got the gold medal for the over 40-year-old division.
That's awesome.
That is great. Well, Troy, I think we're probably kind of coming close to our time because it's like there's a lot of amazing information here. Um, I just wanted to ask, is there any questions that you think would be helpful for us to ask on the show? And any questions you think would be helpful for us to ask you?
Yeah, I mean, there's some of the common questions we are, can you do bigger diameter for like cars and trains, to move people around and larger quantities of freight? People ask about what about earthquakes? How do you line the tunnel?
Mm.
What about if there's water? Those are some of the either technical or interesting things. And for viewers, we've already touched on climate, but for viewers who are curious about how can it affect me in my life, because having more clean energy might eventually lower their bill. Probably not, maybe. But what are the applications for consumers here, or are there any? And so one of the things that we've done is we've signed some LOIs and MOUs with robotics companies who can move Amazon packages around quickly through tubes that are like 12-inch or 18-inch tubes at 100 kilometers per hour. Um, and so you could have a pedestal in your front yard or a little drop box in your kitchen or your garage or whatever, where your Amazon packages can literally arrive in minutes if you have a distribution facility 10 miles away or whatever, and we have a network of tunnels going to actual neighborhoods. So we could be delivering packages, incredibly fast fiber internet, maybe power if we're allowed to compete on the power side. And then the ultimate long-term vision is is transportation. So imagine walking out of your house with your luggage. You go, one block down to the end of your street, and you hop on, you go inside the little elevator that's on the sidewalk, go down into the EarthGrid network, and your app tells you which pod to get onto. You get in your pod, and you pop out in LA or New York or Tokyo, without leaving your pod or your family pod. There'll be different sizes, and it's all going either a Hyperloop or maglev or whatever. That's kind of the futuristic vision that could be possible with this tech. We're talking 10 years plus.
Sure.
Anyway.
In 10 years, I get to
Pretty
walk
cool.
down the street and hop in my
Yeah.
family pod to San Francisco.
I mean, it's possible if we get, like, for instance, if we get enough consumers to say, yes, I want that, and they're willing to sign a conditional contract that says, I'll ride your thing 4 times a year for 10 years or whatever. If we get, tens of thousands of people that say yes to that, there is so much capital out there that will finance infrastructure projects to meet that demand.
You're not short of big vision. That's
It's
awesome.
and we can't do it
Yeah.
all. We probably would license our tech to
Yeah.
whoever to build out that transportation network. But
Yeah. I'm thinking, you're taking the boring company to the next level, you know, because you've reinvented the process of boring,
that's right.
you've reinvented
The
that.
one company reached out to us and asked for proposals, so we gave them 3 proposals last year.
Yeah. And they're doing huge tunnels, right? So you can get trains through them or whatever. So,
Well, not exactly. They're doing 4 meter, 12, 13-foot tunnels.
mm,
So just enough for a Tesla Model X to drive through, but not
yeah.
big for a train.
Yeah. Yeah. I meant their little hyperloops or whatever they called them, the little thing that they were talking about. Who knows? But
Yeah,
very
actually,
cool.
they can't get through hard rock. They have no solution for it. So that's what they asked us to help them with.
Well, and because of private property, which you touched on in your comments, you can't do this above surface anymore. It'd be like trying to do a coast-to-coast railroad. You couldn't do it because there's too much private property involved. It can't happen. So you've either got to go through the air, which is a real problem, or you got to go underground, right? So it's almost the last frontier. It
That's
really
right.
is.
The train company Brightline, they have a great train in Florida that goes, Miami all the way up to Orlando, and a bunch of people ride it, but it's pretty expensive. It's like whatever, $55 or whatever per ticket. And they're trying to connect Vegas to LA. So
Yeah. Yeah.
they're they're close, right? But the land acquisition cost is insane because it's
It's
all
insane.
above ground. So if
Yeah.
they could, we're not there yet, but if we could build them a cheap tunnel using low cost solar power from California, when we have, too much solar and we're shutting off solar farms because it's called curtailment. It's a huge problem. We're shutting them off because the grid can't handle it. We can't export it out of the state. Not enough transmission lines. So that wasted power could be used to bore tunnels really cheaply because we get the power for practically free, barely above zero because right now it's just being wasted. We could bore a tunnel for them and lower the consumer cost of riding that train substantially.
It's fascinating. I'm thinking about, remember the beginning of Star Trek used to be space, the final frontier? All of a sudden, I'm like, no, 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 no. Underground is the final frontier. You
Right?
know,
Yeah.
Subterranea is the final frontier because you're exactly right. And then you could put in, vacuum tubes under there and put people in, they could travel at hundreds of miles an hour in a
Right.
perfectly straight line with no obstruction,
Exactly.
right? So you could go from LA to Vegas in 30 minutes, right?
Totally.
And yeah,
What, so
that's
is there a the question that we were talking about, like the earthquake or the concerns that people might have? Is there an answer to that? Or is that something that's
Oh
just
yeah.
par for
Those
the
are
course?
well understood problems in tunneling, so we don't have to do anything differently.
mm,
Okay.
Yeah, we just, the world's leading tunnel engineering firms, they have solutions. They'll just tell us what type of lining needs to go in for seismic zones. So yeah, it's a well understood problem.
Yeah.
fascinating conversation with Troy Helming, CEO founder of EarthGrid, inventing a whole new approach to leverage below surface transmission of power lines, materials, and eventually even people. Absolutely fascinating conversation, Troy. Not short of huge vision, and can't wait to continue to speak with you and see how this evolves.
Thank you so much, gentlemen, for having me.